Assalamu alaikum warahmatullahi wabarakatuh. Today's lecture will be one of the topics in Chapter 4, RSA Cryptosystem. RSA stands for Rivest, Shamir and Adleman, name of three researchers from MIT that invented RSA in year 1977. RSA is a well-known and widely used public key scheme. RSA is commonly used in asymmetric cryptography. Asymmetric cryptography requires two keys, a public key to encrypt the message and a private key to decrypt the message. Further explanation can be found in the previous chapter, Chapter 3. The basic of RSA is that prime numbers must be larger than 1. It uses mod or modulus functions for encryption and decryption.
RSA, encryption and decryption. Done. So first, an example, we have a public key and a private key. So for this example, I use the public key equal to 7187 and private key is 23187. And I want to encrypt a message. So message M, for example, I want to send a password to a friend, so I want to encrypt it. So the password is MS17. So here we have 4 characters, MS1 and 7. So first we need to convert it to decimal. So you need to refer to the ASCII table. So M is 77, S is 83, 1 is 49, and 7 is 55 in decimal. So how to encrypt it? We need to use the formula, encryption. E equal to M E mod N. So what is M? M is the message. E is the first digit of the public key, and N is the second integer of the public key. So this is E and this is N. So we have 7 different decimals. So we convert it. 77 power of 7 mod N is 187. One is 83 power of 7 mod 187. So just make it down here. Another one is 49 power of 7 mod 187 and 55 power of 7 mod 187. So mod here is the modulus. So you need to use a calculator, or you can use a calculator from internet to get the modulus calculation. So modulus basically is division. You need to divide 187 divide by this number, and then the remainder of the division is the mod. So for this one, we get 1 to 1. This is 8. This is 25. This is 1, 3, 2. So what you're going to do is you will send this number to your friend. It's an encryption. The message is this one. So it's different, right? So how to decrypt it? So to decrypt it, you need to use the private key by using the same formula. So decrypt formula is so M is equal to C ciphertext power of D mod N. So where is D? D is here. N is here. So this is D and this is N. So once your friend get this number, your friend will use the private key to decrypt it. By using this formula, C is 1 to 1 power of D, which is 23 mod 187, 8 power of 23 mod 187, 25 power of 23 mod 187, and 132 power of 23 mod 187. So if you do the calculation, you will get 77, 83, 49, and 55. So basically, this number is similar to the one that you going to send the message. But how exactly the public key and the private key generated? How to generate a key for public and private key? So the first step is to select number at random. So for this number, we're going to use P and Q. So this P and Q, we will use 2 and 7. Remember, before this, I already explained the public key is equal to E N, private key equal to D N. So for public key and private key, the last integer, the second integer is the same N. So to get an N, for the second step, you need to compute N, which is equal to P times Q. So 2 times 7, you will get 14. So these two number, integer, you already get it, 14. The third step is compute Pn. So Pn, you can use equation P minus 1 times Q minus 1. So for this part, 2 minus 1, 7 minus 1. So 1 times 6, so you get 6. So the fourth step, you need to compute or choose E, which is the public key first integer. There are rules to choose E. First is the E value should be between 1 and Pn, which is Pn here is 6, between 1 to 6. And it should not be, it's a co-prime with N and Pn. So for this part, because it is 6, so we have 1, 2, 3, 4, 5, 6 numbers. So 1 and 6, we can slash it, we can withdraw it, and then what is co-prime with N and P? So we need to find, we need to slash or cancel we need to remove or cancel the common factor of N and 6, N and Pn, 14 and 6. So from N here, we know that this is even number, so we can remove the even number from the list here, 1 to 6. So 2 and 4, so the remaining is 3 and 5. However, the common factor of 6 is 3, because 2 times 3 is 6. We can also remove it. So we have the last digit, which is the 5. So we will use 5 as E. So E equal to 5. Lastly, we need to compute D. So E, we already have it, and also we already know the number. So lastly is D. So D, we need to use this formula. E times D mod N, phi N equal to 1. So E and Pn, we already know it. So we need to find D. So E is 5D mod Pn is 6 equal to 1. So for this formula, we know that D can be 11, can be 103, and etc. However, we need to know the rules where D should be less than N. So N is 14. So we can choose this number, 11. So D is equal to 11. So from here, we know that the number is 5, 14, and 11, 14. So we try to send a message to a friend using public key and private key. We try to encrypt we refer to the ASCII table. We want to send STX. Start from text. So the decimal number of STX is 2. So to encrypt 2, use the same formula. E power of, M power of E mod N. M is 2, E is 5 mod 14. So you will send an encrypt text or cheaper text equal to 4. After your friend receive it, he need to decrypt the cheaper text. So he need to use this formula, CD mod n, which is equal to 4 power of d, which is 11, mod 14. So you will get 2. So this 2 is similar to the one that you want to send the message.
Is it possible to attack the RSA cryptosystem? Yes. It is possible by brute force key search if the number is not large enough. It is also possible by timing attack on running of decryption.